Alright, today we're going to be talking about programmable controllers. In today's industry, PLCs can control welders, machines, robots, fluid power, and industrial drives. They can do a lot more than that. That is just a generalization of everything they can do in the industry. So here's some pictures of common PLCs you would see in the industry. You've got Siemens is the big one that Robbie teaches on, Allen Bradley's, Schneider Electric, Mitsubishi. You got all these kinds, but the main one that you'll learn in these classes are Siemens that Robbie goes over with you. So programmable controllers were developed to solve the problem of automating large and more complex control systems. The first programmable controller were developed to eliminate control relays and timers by combining them into one unit that could be programmed and reprogrammed as required by the application. As PLCs became more popular, less expensive, and easier to program and use, a much smaller and less expensive type of programmable controller was developed to control any smaller electrical system in residential, commercial, or industrial applications. So PLC usage. In industrial electrical systems designed to produce products are commonly divided into discrete parts manufacturing and process manufacturing. In discrete parts manufacturing and process manufacturing, PLCs have become the standard components used to control the operation from start to finish. Discrete parts manufacturing. So this type of manufacturing produces durable goods such as cars, washers, refrigerators, and tractors. All machines in this type of manufacturing can be automated with programmable controllers. PLCs allow each machine to have its own unique capability using standard hardware. Use of PLCs helps reduce startup and debug time, allows easy changes to machine operations, and can be used to interface and control the operations of all or parts of the machines along a production line. So just remember that in discrete parts manufacturing, they're producing durable goods like automobiles, washer refrigerators, tractors, your bigger things. In process manufacturing industry, they're going to produce consumables such as food, gas, paint, medicine, paper, and chemicals. A PLC allows for easy modifications to the system in such things as time, temp, and flow requirements of this system changes. So a lot of these machines are going to call for canning and mixing and baking and stuff like that. So they use PLCs in order to control those machinery. So what exactly is a PLC? A PLC is a solid-state control device that is designed to be programmed and reprogrammed to automatically control industrial processes of machine circuits. They can be used to control almost any type of control circuit, but they are mainly used in harsher environments in the industry. PLCs consist of a power supply, processor section, input section, and output section. They can control circuits with many inputs and outputs, and most are designed to be programmed using line, aka ladder programming, or function blocks. Here's just some examples of the programming languages you might see. Line diagrams, Boolean, functional blocks, they're all basic programmable controller languages. Input devices are either normally open or normally closed, just like our contacts in our motor control cabinet. So examine if closed, that's going to say XIC, are normally open contacts. Examine if open are normally closed contacts. Few rules for PLC programming is: inputs are placed on the left side of the circuit and outputs on the right side. Only one output can be placed per rung. Outputs can be in parallel, but never can be in series. Inputs can be placed in series, parallel, or in combinations of series and parallel. Inputs can be programmed at multiple locations in the circuit. The same input can be programmed as normally open and or normally closed at multiple locations. Standard outputs cannot be programmed at multiple locations in the circuit. And last, we'll go over what we're going to be using PLCs for. Now, in this class, you're not going to be required to program PLCs. it's just a good reminder to go over what you should have already learned if you was in PLCs with Robbie. But for our next lab, we're going to be using a PLC to control our industrial drive. And that's what this whole video is about, just to refresh your memory on PLCs, because we need to understand at least why we're using a PLC to control our VFD. So VFDs are available to control the speed of AC and DC motors. They are normally manually set for a desired speed, but a PLC may be used to control AC drives. Drives can accept frequency and direction commands. So as you can see down here in this diagram, this is a program to control motor speed using VFD drive. They're using a HMI on the PLC to program that PLC in order to program that drive to run that motor. Now, we can use that PLC to control that drive in a variety of ways, and you'll see that throughout your labs. But the main thing to take away from this is, coming up this week, you're going to be using a PLC and a drive to control the motor.